So in this situation here, we're given that triangle EDG is congruent to GFE, and we're asked to prove that this is a parallelogram. So we're not told it's a parallelogram. We can see it's a quadrilateral, but we're not told. And so it's important to look at the note up top here. So note the converses are true. Remember, converses mean we go the other way. So the properties are sufficient reasons to prove a quadrilateral is a parallelogram. So we have these properties that say things like you got a parallelogram, then diagonals bisect each other. Well, now you can go the other way and you can say, you got diagonals bisect each other, you got parallelogram. We don't have two diagonals here, we just have one, but that's an example. All right, the converse happens to be true. So let's see here. Let's figure out what we have. We have triangle EDG, and it's important to pay attention to that. So EDG is congruent to GFE. Okay? So when we start to match things up, that means what? We know that ED is congruent to GF. We'd have to say that in our proof if we want to use it. It comes from the triangles CPCTC, corresponding parts of congruent triangles. Okay. We have DG and FE. And then, of course, we have EG and EG, which is this reflexive piece in the middle. Okay. So now you don't say side, 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 because you're not trying to prove those triangles are congruent. They are already congruent. But we have those pieces. This one doesn't really help us. All right. But what do we have? Notice that we have this side and this side of this quadrilateral are congruent, and this side and this side of that quadrilateral are congruent. So by using the converse idea, we have opposite sides of the quadrilateral congruent. Therefore, we have a parallelogram. So, proof. We have triangle EDG is congruent to GFE. That was given. All right. From that, we have ED is congruent to FG. Okay. And that's corresponding parts of congruent triangles are congruent. Okay, because we could do a set of rigid transformations and translate this transform this one onto this one, and they would match up. Okay. Right. And then we have also we said DG is congruent to EF. Also by corresponding parts of congruent triangles are congruent. And those are both pairs of corresponding sides, or two pairs of corresponding sides. And so therefore we have that DEFG is a parallelogram. And why is that? Because we have if two pairs, or both pairs, I should say, if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So basically stating the property in reverse. The property is if it's a parallelogram, then both pairs of opposite sides are congruent. And now we're using it in reverse. And there's the proof.